writing electron configurations. So before you can do that, you have to know the blocks in the periodic table. One of the blocks where the last electron, using the off-brow principle, is added when determining the ground state electron configuration for an element. This region is the S block. This region is the D block. This region, the P block. And this region down here is the F block. So S, P, D, and F orbitals. So write that. So S block, D block, P block, and the F block. Okay. When you transition into these regions as you're adding electrons, that cues you to change the orbital that the electron is going into. So let's do an example. So if you have beryllium, beryllium is here in the periodic table. Its atomic number is 4. That means that when beryllium is neutral in its ground state, it has 4 electrons. Okay, when it's neutral. So 4 electrons. So how you determine its electron configuration is you read as you go across the periodic table. So hydrogen is in the S block. The numbers on the side tell you the period that you're in. And so we start with 1s, jump across, 1s2. Okay. Then we move down, back to the S block, to S1, okay, and then to S2. That is the ground electron configuration for beryllium. Again, where that comes from, start in the first period. 1s1 for 1 electron. Helium's a little strange in that it's actually in the S block. It's grouped over here because it's a noble gas, but so that first row, so adding another electron, 1s2. Okay, so 1s2. Down, the second row, the second period, 2, back in the S block, S1, 2, S2, we've reached the element we're looking at, we stop. So that's the electron configuration for beryllium. If we moved on to nitrogen, it's in that second period still. So second period. So we have in common 1s2, 2s2. That's where we left off with beryllium. And we cross the periodic table, still in the second period, but now we're in the P block. So we have to change the orbital from S to P. Okay, the P block. So 2p1, 2p2, 2p3, and we're at nitrogen, so we stop. 2p3. And nitrogen's atomic number is 7, so that means for it to be neutral, it has to have 7 electrons. We count 2, 4, 7 electrons. That's the electron configuration for nitrogen. The D block is whenever you experience things in the D block, that's where you will start to encounter some exceptions. Okay, So it's important to note that D starts at 3. And what do I mean by that? So, common mistake. So here, 1, 2, 3, 4, the fourth period. So this is 4S1, 4S2. When you cross over into the D block, you drop down to 3. Okay, so 3D1, 3D2, and so on. We'll talk about some exceptions here in a little bit. But it starts at 3 because principal quantum number, and that's the first principal quantum number where you can have a D orbital. Okay. So if we look at the electron configuration for titanium, it's full configuration. So we'll just build up. So 1s2, 2s2, and then 2p. Just titanium is down from nitrogen. So 2p3, 2p4, 2p5, 2p6. You have to keep going. 2p6, 3s1, 3s2. Three P1, 3p2, 3p3, 4, 5, and 6. Down to the fourth row, 4s1, 4s2. Okay. So now here is where we get into entering the D block, 3D1, 3D2. And that is the full electron configuration for titanium. And we look at titanium. Its atomic number is 22. That means for a neutral titanium atom, it has to have 22 electrons. 2, 4, 10, 12, 18, 20, 22. So there are 22 electrons. Those are some examples of doing ground state electron configurations for certain elements. The next video will look at exceptions to these.